The aim of the project was to develop a system of modular apartments that could be disassembled and reassembled in a different configuration on a different site. The site for this proposal is on the east coast of Wadjemup, or Rottnest Island, a small island off the coast of Western Australia. The island is primarily a tourist and holiday spot. However, this was not always the case. The history of the island's use as a prison for Aboriginal men and boys is entrenched into the land. Over 370 Aboriginal men and boys died in custody and were buried in unmarked graves on the island. To protect and preserve the sacred site, a non-obtrusive, low-height and segmented wall was implemented. This solution allows the spirits of the land to flow freely through the site, an important concept to the Aboriginal people, especially with the name Wadjemup, meaning land across the sea where the spirits are. The concept behind this modular housing design is flow. The modules are focused on natural airflow, both within and between structures. This allows the spirits of the land to pass through unobstructed, as well as allowing all units to have natural ventilation from all sides. The housing is placed on top of the redeveloped two-story pedal and flipper structure. The first and second level of modules have the same configuration stacked directly on top, followed by a roof module for each apartment. Planters and communal spaces with tables, seating, and barbecue facilities are located on the walkway between modules. The housing modules are placed in a way that the main wind directions are able to freely flow through the structure, causing less obstruction and letting the spirits flow through. This configuration allows each apartment to benefit from natural ventilation from all sides through the operable windows. The different apartments are made out of a combination of 4 different modules. Each apartment has a living space module that is paired with different bedroom modules to suit the apartment's size and function. A separate roof module is fixed onto the topmost apartments. The finished materials selected are lightweight and durable, with the ability to be reused, recycled, and/or repurposed to work towards a circular economy. The modular apartments are constructed of 200 SHS steel beams and columns, with 100 PFC floor and ceiling joists. The consistent use of these structural members allows each module to fit together easily and provides for flexibility in design combinations. The modules are connected through a bolted sleeve system. The upper half of one module provides a welded SHS sleeve on its extended columns that allow the lower half of another module to slot in and be bolted together. This leaves space between the ceiling and flooring for surfaces. When it is time for the modules to be relocated to Site B, they are simply unbolted and lifted onto a truck to be transported. All modules are built to a 5 meter by 6 meter grid. This allows for flexible rearrangement, as even the walkway modules can be reused in a different configuration. As Site B is essentially a sand dune, in order to protect the landscape, the apartment modules rest on columns. These columns elevate the modules a full story and allow for sand and wildlife to pass easily underneath. Innovative materials and passive design features are used throughout the modules. By microencapsulating phase change materials into the internal plasterboard, the lightweight walls can achieve the same latent heat storage as high thermal mass materials, such as masonry. With this, the structures are able to stay cooler during the hot parts of the day and can give heat during the cooler parts of the night. BIPV is the integration of photovoltaics within the envelope of the building. The PV panels seamlessly integrate into the roofing system, making them ideal for individual roofing modules that may be detached and reattached in a separate location. The PV system allows the modules to generate their own electricity to be stored in an on-site solar battery, and the waste heat generated can be used in heating water. Hydronic underfloor heating is a water-based system that uses sealed pipes of heated water to radiate heat from underneath the floor material. This method of radiant heating allows for more evenly distributed thermal comfort. As a closed system, the water is reused. This heating method can be integrated with the solar PV roof systems to heat the water and reduce operational costs. Structural insulated panels are load-bearing while providing the bracing support that the framing is missing. Zips also provide effective thermal performance and are light and relatively inexpensive, making them a good material for fast construction. Glass wool insulation is produced from recycled glass that has been spun to create fibers. This traps heat and allows the internal spaces to be kept cool in summer and warmer in winter. The insulation is fire-resistant with high thermal and acoustic performance and is 100% recyclable. Planters located on the external walkways between modules are filled with local native plants. Local fauna can benefit from the inclusion of native nature that matches their surroundings. The inclusion of nature within the structure creates a biophilic effect for the visitors, enhancing their stay at the apartments. The facade screen is a perforated aluminium panel with larger organically shaped perforations that prevent direct sunlight from entering into the living spaces, while still allowing daylight, ventilation, and access to views. They are located on all facades except for the south, which does not receive any direct sunlight. They are positioned in front of windows in each module for both shading and privacy. The design references the natural rock formations found in the shallows of the Rottnest beaches. Opposing windows throughout the modules allows for effective cross-ventilation. This passive cooling effect, paired with Rottnest's cooler climate, results in very little need for auxiliary cooling methods, effectively reducing the operating costs of the apartments. The solar PV roofing system is linked with the hydronic underfloor heating system. The waste heat generated from the solar panels is transferred into water pipes that carry the heated water to an exchange tank that facilitates the hydronic system. All plumbing pipes travel vertically through a plumbing duct and exit horizontally towards the mechanical risers on the lower floor. When reconfigured, these ducts will still line up. Thank you.